This is a featurette about today's lunar eclipse. Now, I had planned to do a featurette about the new Star Trek series, so I'll probably do that next week. But when I got on to do some research yesterday, the first thing I saw was it's going to be a lunar eclipse, a total lunar eclipse tonight. And I started researching it, and the further I got, the more I needed to know. And I ended up 4 or 5 hours later realizing that this had to be today's featurette. And so I hope that you enjoy it. This first slide is an artistic mosaic of a lunar eclipse. It is not intended to be a realistic diagram of how the moon travels, but it's mighty pretty. And this is a description of the different kinds of eclipses. I know some of you already know these things, but it tends to confuse me. Even though I've learned them many times over, I still get confused. But a lunar eclipse, like we're having tonight, is when the Earth passes between the sun and the moon, and therefore the moon is in the shadow of the Earth. It's eclipsed by the Earth. Now, a solar eclipse is when the moon passes between the sun and the Earth, and the shadow of the moon appears not all over that side of the Earth, but in a smaller area than a lunar eclipse. But the shadow of the moon will fall upon the Earth, and that is an eclipse of the sun, as the moon blocks our view of the sun. And the third kind of eclipse has not yet happened. It's very rare. It's exceedingly rare. But should the sun ever get between the Earth and the moon, that would be called the apocalypse. So I hope you enjoyed the joke. I just think it's so cute. So now we're going to get on to some serious things. This is actually a diagram of what's going to happen tonight. The times are in universal times, so don't write them down. I've got another information piece for you on that. The moon moves from the right to the left, so it will be coming from the right. It'll enter the shadow or the penumbra of the sun, and then it will be partially eclipsed as it keeps on moving into that shadow. And then it reaches what they call totality, or the full eclipse. And as it keeps moving, it leaves the shadow. And then again, it is a partial eclipse, part in the shadow, until it is done. This is a chart that I'm going to leave up for a minute because you might want to copy some of this down. The stages of this eclipse are going to happen tonight at these times. These are Pacific times. It's going to enter the penumbra, or the shadow, at 6:32, but we will not be able to see it. The moon will not have risen high enough above the horizon. It always happens during a full moon, and the full moon has got to rise in order to see it. Then about an hour later, it's in the partial eclipse, and we can't see that either. That's at 7:30. And where I would recommend you start watching would be about 8 p.m. Because as this chart says, at 8:29, the full eclipse begins. And I would assume that the moon will be visible as it continues to rise. It'll be visible sometime between 7:30 and 8:30 p.m. Then at 9:11 p.m., we'll have the totality, the maximum eclipse. And at 9:53, that part will end. It'll still be a partial eclipse until around midnight. It'll all be over. Maybe nothing left to do but sweep up the popcorn and throw away the soda cups. Another thing that you might want to know is that NASA is live streaming the eclipse on YouTube. So even if it's cloudy and you can't see it, you'll be able to watch it on YouTube. And that'll be a great convenience, I think, for most of us. I kind of like sitting in a chair in the driveway, but I like it better when I'm all comfy and cozy on my couch. So the times you really need to write down are from 7:27 to 9:53. Make a note to start watching by 8 o'clock. This is a simple diagram of the sun and the moon and the earth. And we see that the earth goes around the sun in its own orbit. That's called the ecliptic. And the moon goes around the earth in its own orbit. Now, I really struggled yesterday to try to get this all pictured in my head, how this happens, why it happens as often as it happens, why sometimes it's total and sometimes it's partial. And I just couldn't understand. I really struggled with it. And I ask you, have you ever wondered about the moon's orbit around the earth? Have you ever wondered just what is the path that the moon takes as it orbits around our planet? I had never considered it until yesterday when I couldn't get anything to fit together because I had made an assumption. I could not make sense of the eclipses based on my current knowledge and assumptions. And I think I had assumed that the moon's orbit followed the equator, right around the center of our planet. I'd never questioned that. But I discovered that it does not at all. And when I discovered that, when I found that piece of information, that piece of the puzzle, I do believe I scared my dog because I had a eureka moment. I'm like, yes, finally, the missing piece. I get it now. I understand. My dog's kind of shying away from me. So we look at this particular diagram, which is a little more complex than the last one. And we see now this line here, the Earth's orbit goes down here and it would continue going around the sun. And then we see the moon's orbit around the Earth. And we start looking at the shadow that the Earth creates with the sun shines on it and what part of it actually reaches the moon as the moon travels behind the Earth. And we see the penumbra and the umbra. The next diagram is more complex, but it's worth the effort. This is where it all comes together. The Earth's orbit around the sun is the ecliptic. It's the ecliptic plane. So it's this red line that goes straight through the Earth. Well, we've talked on many occasions in the past about how the Earth is tilted on its axis. It's not straight up and down relative to the ecliptic. And so when we look at the equator of the Earth, right around its middle, and this is the equatorial plane, this red line that goes this way. And we notice that indeed that is not the orbit of the moon. Here's the moon, and it is not anywhere near going around the equator of the Earth. As a matter of fact, it's closer to the ecliptic, but it's not exactly the same. It's 5 degrees apart. You see over on the right-hand side. and it's 23.5 degrees from the equatorial plane. This is another picture of the same thing at the bottom, where we've got the Earth. The ecliptic plane is the orbit of the Earth, and it shows that the moon's orbit is 5 degrees from the ecliptic. Well, now that explains why these things don't seem to happen any more often or on any more of a regular basis. It seems like it should be regular to us humans. Why doesn't it happen every time we have a full moon? The points at which the moon's orbit crosses the ecliptic are called the lunar nodes. There's one right here, and there's one right here. Lunar eclipses happen when a full moon is near one of these nodes. Partial lunar eclipses happen 2 to 5 times a year, and full eclipses happen every 2.5 years. That's one of the reasons why tonight's is so special. Solar eclipses happen when a new moon is near one of these nodes. A new moon is near where the moon's orbit is crossing the ecliptic. I don't expect anybody to remember or even understand this the first time. I know I won't. I'll have to review it. So then I wanted to go on to a related issue, and that is why tonight's moon is called a blood moon. And this is a picture of the Earth, and the sun would be on the left of it. And the sun is shining like the Earth is in the way of the sun. And the red rays are the ones that go through the Earth's atmosphere. On Google, I read that the same phenomenon that makes our sky blue and our sunsets red causes the moon to turn red during a lunar eclipse. Light travels in waves, and different colors of light have different physical properties. Blue light has a shorter wavelength and is scattered more easily by the particles in the Earth's atmosphere. See, the blue light ended up farther away. And it's scattered more easily than the red light, which has a longer wavelength. And during a lunar eclipse, the moon turns red because only the sunlight reaching the moon passes through the Earth's atmosphere. And the more dust or clouds in Earth's atmosphere during the eclipse, the redder the moon will appear. It's as if all the world's sunrises and sunsets are projected on the moon. I think that's a very poetic way of putting it. And then I was going to share one more slide and one more kind of related phenomenon with you, something that's always fascinated me. And this is about the tides. And if you look at this diagram, you'll see it's animated. It actually is changing. It changes from the spring tide in the upper left-hand corner. It has a little box and it'll say spring or neap, N-E-A-P. And it'll show the position of the moon as compared to the Earth, and the moon goes all the way around in its orbit. And it changes when it's the top or the bottom, it's a neap tide. If it's on the left or the right, it's a spring tide. If we look at this diagram down at the bottom, the yellow circle around the Earth is the tidal bulge from the sun's gravity. Then there's a gray circle around the yellow circle, and that's the tidal bulge from the moon's gravity. And then there's this dark kind of charcoal circle around that. And it's the total tidal bulge of the sun and the moon, all of which are encircled with this white circle. So you see, when the moon is on the left or the right, it's pulling this bulge this way. And if it's at the top or the bottom, it's pulling the bulge that way. One of the things to know is that the spring moon has nothing to do with the season of spring. It has more to do with the idea of springing forth. And the neap tides occur during the first and third quarter moon, when the moon appears to be half full. They appear 7 days after a spring tide. Tides are like great big waves that are moving over the surface of the earth, the entire surface of the earth. And so, in closing, I'd like to remember that we are surrounded by the beauty and mystery of God's good universe. The more we know about it, the more we become aware of the awe of creation. So remember, this evening around 8 p.m., look to the east and enjoy this spectacular show. And thus ends our featurette. Thank you for listening. Thank you for letting me share.